Hello and welcome back. So this will be a rather short lecture on issues of replication and generalizability. Okay, so I popped this in here kind of in between some of the design stuff because I think it's important to talk about this after we've talked about some confounds. There are issues of being able to replicate the same effect. It's important that we don't just run one study, we run multiple ones. And then we also have to say, how generalizable is this? Some issues of external validity. So first, before we get started, I want you all to watch a separate video that I've provided the link to in my email and also on Blackboard. It's basically this link here, if you can kind of see it and hover over to it, where John Oliver does a segment on scientific studies. So watch that clip for about 20 minutes. It's a really good and funny clip, so I highly recommend you do that. It's a really nice primer to what we're going to talk about. So go ahead, pause this video, watch that, and then come back to me. Okay, so welcome back. So, John Oliver brings up a lot of good issues of, replication and also some good things just overall that we've talked about throughout the semester, right? This idea that like smelling farts cures cancer, and these kinds of claims in the media, right? And he talks about this kind of pressure to publish. So we'll definitely go through some of these issues in more detail now. So sometimes when you conduct one study, we work in the realm of probabilities. Just because you find some results doesn't mean that's the end all be all of things. That's why I'm so strict with you all. And whenever you say prove, it drives me nuts. Nothing is ever proven, not especially in psychological science. We don't prove things, we work in probabilities. And even then, the p-value, null hypothesis testing is rather flawed because it's not really telling us if there are differences between these groups. It's actually telling us the probability of detecting these effects if there were no differences. So it's assuming that there are no differences, not telling us that there are. It's very strange. But anyways, I digress. So you might ask yourself after a study, are my findings a fluke? Can we draw conclusions from one study? Right? And so this is this issue of reproducibility. You want to know, can you reproduce these findings after one study? So one study might find something, others might not. And so our initial findings might be reliable. So finding an effect when one doesn't exist is type 1 error, remember, right? So usually it's not good to draw conclusions from one study, especially when it's a new idea. So it's fine that you have conclusions, you have a discussion section. That's all expected of you. But you can't make sweeping conclusions that, oh, well, because I found differences between defendant race and verdicts, there's always going to be, that we've proven that there's always discrimination based on race. Well, that's untrue. That doesn't always happen. And in fact, right now we're actually seeing some interesting effects there that are changing the face of race research in juror decisions. And so your findings, you can't be so definitive. You can say these, of the data given, this is what I can conclude. Here are my limitations. There you go. You can't just say this is the end all be all and we're done, right? So there's this problem in psych science right now. I hate to say it's a problem, right? But people call it the replication crisis, right? And so John Oliver talked about this a little bit in the video, and so did some researchers in the video. And so some of our previous research findings don't have as strong of an effect as we previously thought. So somebody probably maybe published the study, some journalist thought it was cool and sexy, and then we just kind of took it as it's an effect and it exists. So one of these effects, for instance, is our facial feedback hypothesis. And this is the idea that if you force like a smile, then that will trigger mechanisms in your body to then feel happier. So if you bite on a pencil and put it in between your teeth, you simulate a smile, and that should then make you feel happier. facial feedback hypothesis. However, this effect has really struggled to be replicated beyond just the original researchers who can replicate it. And so this can mean a couple of things. One, they're doing something so specific that it can only be replicated in their lab conditions, which is bad. It's not generalizable. Or maybe everybody else who can't replicate it, their methodology is flawed and they're just not reporting it very well, so we can't tell what's going on. Right? But we have to take this into consideration. Okay, so, right, so replicability in its basic form is just repeating an original study to determine whether one can find the same results. There are different forms of this. You can have direct replication, where people repeat the original study as closely as possible. Okay, so they do the exact same thing. The problem then becomes that then there are internal validity issues or construct validity issues that can carry over. So if the original research had internal validity issues, they had a confound that they're not controlling for, or they have a construct issue, their measure sucks, something's wrong with it, then if you're using the exact same instruments, this can carry over, right? So this becomes really problematic. For instance, let's say you are running a study on looking to see if container size affects food consumption. So whether or not people serve themselves in a big bowl or a small bowl might affect how much food they actually eat, right? So let's say the initial study didn't control for whether participants ate before the study. And so maybe the ones that are being tested with the large bowl are being tested right around lunchtime and people haven't had a chance to eat, right? Maybe people use different foods, or they had some order effect issues. They didn't control for that. This can carry over to people who do direct replications. You can have conceptual replications where, again, this is more about your variables are conceptually similar, but you change the operationalization of the variable. In other words, your definition is still the same, but the way you're going to manipulate it or measure it is going to be different. So, an example of this, back to our container size and food consumption, right? Let's say you're going to manipulate, or the original study manipulated the size of the bowl, big bowl or small bowl, right? So then let's say, well, we're going to look at how much people consume soft drinks, right? Sugary drinks. And we're going to give them a big cup or a small cup. Conceptually, you're still measuring this idea of container size. But operationally speaking, you're now changing it from bowls to bottles, right? We're looking at a different kind of food. So you can also then, your measure could be how many chips they eat, right? So let's say you give them a big bowl, small bowl, you see how many chips they eat, right? So then you measure this, or you look at something like popcorn, how much popcorn they eat, right? So again, conceptually, everything's the same. We're looking at food consumption based on container size, but you can change the type of the container and the type of food, okay? So this is this idea of a conceptual replication. Another kind of replication is replication plus extension. So you replicate the original study, maybe it's direct, maybe it's a conceptual replication, but you add variables or you add conditions to the original study. So this is particularly good if different labs replicate, somebody else's findings. So of course, if you're a researcher and you look at food consumption and container size, that's your jam, that's what you do. Of course, you're going to be doing a lot of the same studies within your lab. So it's good if somebody else from across the state, in another university, whatever, does the same research and can replicate what you've done, right? So this is always really good. Otherwise, it means that you only find this effect under very specific conditions found in that lab, right? That's not good for generalizability or general reliability if your effect can't be replicated by others. So a couple of examples here are, let's say somebody originally looked at using a cell phone in driving. Does cell phone use impair your driving ability, right? So that's the original study, but somebody might say, hey, I want to look at age. Okay, so yeah, we know that cell phones affect our ability to drive, but are younger people a little bit better at driving and talking on the cell phone compared to older individuals, where you might start to see, declines in cognitive abilities, right? Reaction time and stuff. So you might want to be interested in race of the defendant, right? You're like, okay, race of the defendant predicts guilt. We've seen that time and time again. What might be more interesting is to say, okay, let's see if we can find the original effect, the main effect there. But then let's throw in victim race. So we do know that, with death penalty cases, for instance, Black defendants tend to be, sentenced to death more often than whites, but this is particularly pronounced when the victim is white. Okay, so Black defendant, white victim, you get death way more often than, white defendant, white victim. Okay. So race of the defendant affects guilt, but the victim is another piece of the trial that could affect the guilt. Replication plus extension, you're adding something to it. Okay, so those are various ways you can replicate. There are other ways we can check to see if things are being replicated in the literature. So, it's one thing to replicate, like, and you have one study and then you draw some conclusions, but it's nice when researchers do one of two things. You can do literature review, for instance, and this is just, this is what people do at the beginning of, their introductions, but this is more extensive. So literature reviews or review articles are a summary of related studies. So an example of this is a pretty classic paper that was written, it's a little oldie, but it's a goodie, 2001, by Dennis Devine and his colleagues, that looked at 45 years of research on group decision making, jury decision making. So a lot of the times you find this in, book chapters or, edited volumes. People will summarize a whole area of research, like, research on lie detection, what we know about it. And again, they're just summarizing it. They're saying, okay, we're going to look at some procedural characteristics, case characteristics, participant characteristics, deliberations, and we'll kind of sum up what we generally find, right? And so this is telling you at least something about what does most of the research suggest about jury decisions, what impacts it, what doesn't, okay? Meta-analyses are another way to go. A meta-analysis is when researchers pool or combine data from similar studies, and then they come to one decision about some effect of interest. Okay, so they'll average effect sizes across studies that examine the same kinds of variables. And so this is a statistical procedure. This goes beyond just eyeballing and reviewing a bunch of studies. Instead, you're systematically looking for specific studies on a particular topic, looking at the effect sizes and saying, okay, more often than not, do we find a significant difference? In other words, do we find this effect and is it reliable in the population? So it's usually referred to as a study of studies. An example of this is a really classic, a really good meta-analysis by Pettigrew and Trop, and they looked at the intergroup contact theory. Okay, so in 2006, they published this paper that looked at, 515 articles that, really included about 250,000 participants. 94% of these studies found that when you have positive or good contact with an intergroup member, somebody of another race of yours or another, part of an outgroup, you tend to see reductions in prejudice. So this gives us statistical information. It tells us, inferentially speaking, yeah, the contact theory seems to be pretty reliable. Across 515 studies, which is massive, we do find reliably that when people have close contact with outgroup members, they tend to reduce prejudice. Okay. And so these are really great ways, particularly meta-analyses. They really help us determine, were these effects reliable, right? Do you see them over and over and over and over again more often than not? So it's a study of studies, right? So you're kind of looking at, our sample is studies, and then you say, how many find this effect and how many don't? And do the ones who find the effect, does that kind of outweigh how many don't find the effect? So there are still problems with meta-analyses. These aren't perfect. One of the biggest problems is the file drawer problem. This is that the idea that meta-analyses are overestimating true effects in the population. Okay, so they're saying that we're finding these effects more often than not because they're excluding any null effects or opposite findings that might not get published. So sometimes papers don't get published because they don't find any effects or they find the exact opposite. And this becomes a publication bias problem. So meta-analyses don't typically or used to not really include unpublished studies. For a long time, people only looked at published studies because those are easier to find, right? Unpublished studies, it's really hard to find unless you know people who do that research and you know they have unpublished studies on it, right? So not everybody knows everybody. We're not going to know about unpublished studies. So this points to a problem in the publication process. There's this thing called publication bias where, and this is a real effect, like you can study this and find this, null effects are less likely to be published than significant effects. So if you find no differences, when you expect to find differences, okay, so this is different than, well, if you expect to not find differences, then they'll probably publish it. But when there are expected differences and you find null effects, your paper is less likely to get published because people kind of, I think what's going on here is they assume that you didn't do something right, and that's why you didn't find the differences you found. So there's a methodological issue, and they're not going to publish you. So then this gets stuck in the file drawer. So you don't you have no findings, it gets stuck in a file drawer somewhere. That's what, historically would happen. And you kind of just, give up on publishing it because nobody will publish these papers, right? So this is our file drawer problem. The meta-analyses typically don't include these null effects that don't get published. And so now you're overestimating effects because now there's an overrepresentation of papers that have found effects. So you've got to be real careful, right? Meta-analyses are overestimating true population effects. The solution to this is to include unpublished studies. And so then you evaluate the methodology there and you talk about it in your paper. And this is becoming more and more common in meta-analyses now. So you can contact researchers, and sometimes you can do this through membership. So a lot of psychologists are members of the American Psychological Association or other kinds of organizations like the American Psychology Law Society. And so if you're part of that organization, you're usually on some kind of listserv, you're on an email chain. And so researchers can reach out to these listservs, to these email groups and say, hey, I'm doing a meta-analysis on, stereotype threat, or whatever it is, and say, hey, can you, do you have any research that you haven't published on this? If so, would you be willing to share this information? Okay, and so this helps to get around some of these problems. And one final thing on reliability, or reliability and replication and generalizability. So generalizability, again, is referring to external validity, the extent to which the results of a study can be generalized and applied to other contexts and peoples, right? So when you do conceptual replications and replications plus extensions, right, versus direct replication, this increases generalizability. So direct replication is not going to increase generalizability because you're not changing anything. So the only thing you're changing is maybe getting a different sample of students or participants, and that's it. But if you change your methods, right? So you use different, you use chips, you use popcorn, you use cookies, you use different kinds of foods, and you conceptually replicate both, container size and food consumption. Then this generalizes. This means you see this effect of bowl size or container size on food consumption across many different foods. If you do an extension, right, you maybe add in, well, let's also look at the time of day. Let's look at other dietary restrictions. This is increasing generalizability because now you're saying, okay, do we see this across other areas, right? So this is going to really increase your external validity. So examining different settings, different populations. Sometimes this means focusing on increasing ecological validity, meaning you want to know, okay, let's say we're checking out race of the defendant affecting juror decisions. So is this going to replicate, with an ecologically valid sample, with real jurors. So you might look at data from real jurors, you might try and recruit real community members to see if this is generalizable. So ecological validity helps to get at external validity, this generalizability issue. But that doesn't mean that artificial lab settings aren't helpful. They are. This is going to help, maintain the balance of internal versus external validity. So it's still good to maybe, you do replications plus extensions, but you still have high control over your factors. So this can still help with generalizability. And even though you're in these artificial settings, you're still adding other variables to try and simulate a more realistic setting, right? So even even conducting studies in the real world might not replicate everyday contexts that we see, but it's still okay to do these kinds of artificial lab settings. And so that's all we've got for the replication and generalizability chapter. And so I will see you all next time when we're talking about alternative design.